Let's consider or simulate the energy use of our project now. It's going to start with a thermal analysis simulation in Climate Studio. Before we set that up, I want to talk about a couple of general things. So far in this class, we've only talked about rectilinear, um, planar surface geometries, and that's been for a reason. So now we have a curve, an oval building. If I want to run a daylight availability study on this, you see it works just fine. So we can, if you have uh, curved surfaces in your studio project, you can use them in your daylight analysis. However, for um, thermal analysis, it's a different story. If I try to make a zone, I can make a zone out of it, of the curved space, but if I run it, I get a failure. Now, it looked like nothing ran, but it did run. It just was very quick, and we see we have a severe error, basically saying that we don't have any services. So, by the way, if you get that kind of a glitch where you try to run a thermal analysis and it just blinks on and off really quickly, it's because not that it's not working, it did work just very quickly, and you can pull down and look at these command lines up here. There's sometimes there'll be a lot of them, and sometimes you can solve the problem just using your common sense. Okay, so what do we do if how are we gonna run a thermal simulation with curved surfaces? Well, we can build a volume that has a similar measured volume. So if I have this curved space, the volume is about 76,000 cubic feet. I can make another volume, a rectilinear volume that has a similar measured volume. That's 90,000. Maybe I want to adjust it slightly. Um, 80,000. We're getting closer. So, whatever you get it as close as you feel like you need to. Um, and the point is that now if I let me delete this. Now if I turn this into a zone, a thermal zone, and run simulation, it works. And so I could add glazing in the same way and get an output. And okay, so this isn't exact, but we didn't know anything about the energy use of this building. And if we can get something that is 50, 60, 70, 80, 90% accurate, then we're learning a lot. And that's all we're trying to do is learn something about our project, about its performance. The other thing that I've noticed is people just, and it totally makes sense. You're modeling for architectural reasons when you start your projects, and you're not thinking about things like you didn't even know about thermal analysis, and so you're creating geometries that are not going to work, and often they're just inexact. You've got overlaps, you've got you know just idiosyncratic out of plane curves that you thought were actually a rectangle on a plane, but they're not. So the way to solve that is definitely do not do this to make a surface and then pull that up. Um, Even if it's off just a little bit, that's going to mess you up. So I would use the box extrusion tool. Um, Remember sorry, if you keep your O snaps on, use your gumball snappy draggy setting, and you can very quickly make these geometries relative to other things. So let me go back in here and delete that zone from before. So if I make this into a zone, just want to do a little review here. You see that I have a bunch of exterior facades. It's hard to see them because of the color stuff I've chosen, but you can see I'm going around the outside. Exterior floor is the floor, and the roof is the roof. And that's all determined internally by the simulation. It's based on Energy Plus. It knows based on the context of where you put it in Rhino how to consider these surfaces. And an exterior wall is going to be different than a floor than a roof in terms of heat loss. That's our heat movement. Okay, so if we now then take this same volume and we want to turn it into two volumes. And let's not make it the same. I don't care. Just make it the same length. Now, what's going to be different? If I turn these into zones, and I open a zone, you see I have a bunch of facades and a partition. The partition's in the middle, and so that's going to have a different profile of heat moving through it. If these are exactly the same, like if they're both classrooms and they're inside, it won't have any heat movement through that. So that'd be like an adiabatic surface, one that where you just are saying there's nothing happening there, basically thermally. Um, so it's very important that then you, when you're building these zones, that they're simple and they are coplanar where they need to be. If you the other thing as you're building these is as you build each zone, um, do what I just did. Make them zones. So I built the geometry. I can delete this now because I'm not using that anymore. Um, and then run it. Run the simulation. If it works, then you know um, that you don't have a problem, right? It ran. And then if I make another zone and then I can't run the simulation, I know that that zone is what caused the problem, and so I can very quickly fix it. Whereas if I build a whole complex model and then I start trying to run a simulation and it doesn't work, it's hard to troubleshoot. Also remember that wireframe um, is where I can see what's going on in my thermal model. So by the way, these are turned off. So I can see that these are fine. And if I add windows, they'll be blue. If there's a problem with the window, it'll have a red border around it. So you can check that in the wireframe in the thermal analysis. And I would do that as you go so that you know what's going on. So the other thing that well, let me see, what's the best way of doing this? Okay, so if we go back to we had a daylighting model, and this is it, right? Um, in my case, my thermal model is very similar. One difference, if I turn this to um, my daylighting model, I built the full building as a single geometry because I didn't need any more. I'm just creating work planes inside of wherever I need them. And that was the simplest and made the most sense. Of course, I can't do that with, well, maybe that's not immediately obvious. I can't do that with a thermal model because if I made all of this one big volume, it would just think that I had a floor at the bottom, on the first floor, and the rest of this was just open space. So that's not going to be accurate, right? Because if we have, people in here and people down here, we the way that the model knows that is based on that there's a floor there. Um, so we just need to think of the volumes of space and create zones uh, that reflect those. But again, if you have a complex architectural model, so I mean, here's my architectural model is very similar um, because of the way I built this. Um, you can't even tell the difference from turning it on and off. But if yours is more complex, just do what I said before. Be very careful. Just use the box extrusion. Check your zones as you go. So I have built then, uh, I have these zones. Let's see, sorry. Go to, these are the zones that I've created. Let me do this. What else do I have besides just these exterior zones? Of course, I have windows. And remember, the only trick with windows is they have to be single uh, planar surfaces, and they have to be coplanar with the um, the exterior surface or a surface in one of your zones. So if that weren't the case here, if this were pulled off a little bit, it would be red. And you check that by looking in your wireframe view here. Make sure that your wireframe view, not your ghosted, um, and make sure that everything's on. And by the way, you can turn on and off previews here with this setting. So the default should be that they're all on, and that's where you want to have them until you get into other, like I think in the HVAC, I turn them off. Okay, so I've got windows, and so thermal zones here, windows here, interior glass you can install. I wouldn't really worry about that if I were you right now. I'm just trying to kind of keep this simple. Um, but let's talk about the zones then. If we go back to my architecture, I'm going to turn on my plans. I set this up in a very straightforward way where I have, let me turn off my buildings. I have a basement, which is a mechanical room. It's just one zone, one box. Then I came and I made a box for the first floor gallery, box for the, um, I had my architectural zones on also. So I have a box for the first floor gallery, so it's a zone for the lobby, two-story zone for the theater. Then this office out here is a separate zone. Same thing here with this rehearsal space. And then I have two zones upstairs. I mean, on the third floor. One's the kitchen and one is the restaurant. So now I have all these zones, and then I have the windows in place. I had a little bit of a complex, since I have a basement, I have a number of surfaces. Oops, I think I just have those as a unit here. Let me go see. Yeah. All of these surfaces are the ground, because if you think about it, here's the basement, ground's all around it, underneath it, and then there's ground here underneath this floor. So that's important. Either keep it really simple and don't do that, or if I, like for example, if I had this ground moving all the way underneath this building and I had the basement with grounds around it, it would not work, or it would have I'd have some kind of error. So it might work, but it would be incorrect. So that's the ground, and that green, right? So I've got the white is the thermal zones, the blue are the windows, and the green is the ground. This will work if I don't set a ground. So if you're in a real hurry, I mean, it won't be as accurate, but we just also need to get outputs here. So I've got the zones within. By the way, if you don't know this, haven't noticed this, the windows are inside the zones. Um, so So like this is the facade here on this gallery, and that's the window there. Not that you really need to know that, but they're inside. The windows are inside the zones. And then I have my ground boundaries, right? And the last thing I would need to add in this case would be shading. And I have a couple kinds of shading. For one, I have the shading in front of the south facade. So I'm going to need to turn that into shading. So I select it and come to here, no here, sorry. And we can see that it's been chosen. If I turn off, this is another thing to remember that in the thermal zone, the thermal simulation, what's on in the graphics window is not necessarily what's on in the thermal zone. So if I have, this on, or, you know, it says that the shading's off, but it's not off. It's actually on because I put it into the model. I'd have to delete it from the model for it not to be having an effect. So I need other shading though also, and that's the buildings on the site. And this is something that's a little bit funky, and your simulation will work fine if you don't have buildings, context buildings. It just won't be as accurate. But you'll notice that I've actually exploded these buildings. Like this one I didn't. So if I can bring this in as a shading element, let me do that. Um, it's interesting. Maybe it was grouped. The point is that what it just did needs to happen. It needs to break up all if you have a building that does not, that's a group or that's a polysurface, you need to um, explode it. Let me see if it works with this one. Yeah, so this is either, I can't remember if I exploded these myself or if the model does, but I think you have to do it yourself. Um, anyway, the point is if you want the context to work, they need to be single surfaces. And so you get a huge amount of shading. But if you click through it, it'll all, it'll represent a shading surface somewhere. Oh yeah, I'm seeing that. I guess I had done both of these. You see, this is that full. So if I wanted to add all of these, um, I would have to explode it. It's not really important in this context because it's not going to add much shade, so I'm not going to worry about it. Okay, I've got my zones, my shading objects, and my ground boundaries. The most important thing to realize here is that all I'm really concerned about for thermal analysis at this level is that I'm encompassing as much of the volume of the building as I can. And I want to run that as a single, I don't want to do a single room. You can do that for daylighting. It doesn't really work well for thermal simulation. If you think about, there's kind of, it would make sense why. Um, okay, it was bugging me, so I went back and fixed the shading. It is that you have to explode everything, and it can't be grouped. And you'll know if it worked if you can if it's gray in the wireframe. So I have all this shading now. Uh, that's part of my simulation. But the thing I was trying to say is keep this simple. All you're really trying to do is get the volumes of the building to be represented and the amount of floor area that you have. So that's what, like I made a, I've got the theater as a single volume because it's a two-story space. It's easy to model these separately. Um, and I could go back in and change things later, but it was the simplest way of modeling this to have the kitchen and the restaurant separated. This is, cantilevered portion of the building is easy to model by itself. My point being that I, sorry, just changing a couple things. All right, remember, if I'm in wireframe, this is where I see what's on. The reason these are ghosted right here is because I don't have them actually on in the model, but they're still on in the simulation. So I was trying to go back to this so I could have more control. Um, now the question, so I've got everything set up, and it's smart to go in there and name your different zones so you can be clear on what's what. What I'm suggesting to you to do um, is select all your zones, and I've already made these into zones. I've already given them a template, so um, because I ran this before. But so I'm going to edit all these, and if I come over to this setting tool, I can say apply template. That gets me to this library. And if I type in WH for whole building, I get a bunch of whole building templates. And what these are think of so these are very energy efficient. So you're going to do well if you use these probably because it's taking all the settings we learned about in the loads, conditioning, envelope set, and the cost settings and carbon settings, and setting them to first of all to meet some standard. And this NECB is a energy efficiency standard. Um, CZ4, CZ5, these are the climate zones. But it's basically saying, okay, for example, I'm going to use performing arts. Let me find that. Because it's a library, I mean, a gallery and the theater. That seems like a performing arts space to me. I'm going to choose CZ4. And but since this whole building, I'm going to be able to take all my zones and just give them the same template. I'm not going to change anything. I'm just going to run it. And what it does is it says, okay, we know there's mechanical room, we know there's bathrooms, we know there's corridors, and that it's not all, so there's going to be different mechanical system settings, there's going to be different occupancy, number of people in the different zones. We're just going to create one set of inputs that we're based on our knowledge and our this survey that we've done, DOE probably, this is a different organization. We're going to decide what those settings should be, and it'll be good enough for the entire building. So rather than going in and trying to, nitpick and try to find the right settings for each, or even the right templates for each zone, we're going to pick a whole building and whatever you think is the closest to yours. There's a bunch of them here. You can pick whatever you think is closest. Um, or pick whatever you want. But I'm saying that I would suggest you pick a whole building um, template and apply it to all your zones. Then I ran that and see that I got already incredibly good performance. I'm 64% below the baseline. Let's just remind, I don't want to spend too much on this time on this because we've already taught these things and we've done as good as we're going to do. But I just want to let you know that, so this use type here, this is where that benchmark comes from, the baseline. They took a bunch of performing arts buildings from around the country, the United States, or wherever this might be a different country, this particular or a different organization, whatever. It doesn't matter. There's a group of buildings that were surveyed, and they separated them into different building types and created sort of a baseline average for a decent building, or let's just say a decent building, and then that EUI becomes the baseline, and then you're comparing yourself to that, right? So if I go look here, that's what this 95 would be the baseline because of that setting that we did for that particular. Um, Actually, maybe it's even good to do that. So if I change this to library, well, actually, I didn't do it for all of them. So it would change that baseline. It wouldn't change if I ran it again, it wouldn't change our side EUI, but it would change the baseline we're comparing it to. So we've already done very well. That's all we'd have to do really. If you're trying to go quickly, we've set up a building template and run it. The one thing I didn't talk about is remember that you have to set the glazing. So if I select everything and go to edit something, takes me to, I'm going to say, okay, I don't want to change anything about my envelope, so I'm okay, and then it takes me to glazing. I picked a sort of mid-range, um, so we have a U value of about 0.5, a solar heat gain coefficient of about 0.5, and a T-vis of about 0.5, visible transmittance. You need to pick something. I would suggest picking something that's middle of the road. That doesn't come with the template. So I made my zones, have my windows, created the ground, and I added shading both in terms of the building itself and I guess I got rid of that shading. So let me go add that again. So I'm being a little bit less. Let's see, where are we here? Come in and add all of those. And say that's shading. And there it is. You see it's gray, and if I can turn it off here, it's still going to be there. So that's in my model. I set that up, selected one template, ran it, and this is the output I got. I'm done if I want to be for this assignment. I can also optimize a little bit, and one way to do that would be to do the natural ventilation. So let's go over that. If I go into Grasshopper, select the natural ventilation script. All you have to do here, actually, this is probably already screwed up because I should. Oh, it's not enabled. You have to enable this to send these schedules to. What's happening here is this is actually just creating schedules that it's sending to um, Climate Studio, and I'll show them in a second. Just to remind you, you have to pick a name in the script. I just called it Climate, so I would put New York City or whatever you want to put in there, you'll see that this comes um, in Climate Studio, and I'm just setting, this is the range I want to have inside. It's going to be between 64 and 78 degrees. All we're doing here is saying, okay, this is the weather file. I have to pick one. I picked LaGuardia. Um, by the way, you may not have all these. This is because I use this a lot. You may just have a few, and because they're coming inside this component. I'm converting from Celsius to Fahrenheit, and then all that's happening here is that we're saying anything that's larger than 64 but less than 78. Tell me all those hours, and this is them. And then we're saying, okay, what hours are not within that range? And that's this schedule. And so what is that? What are we saying? We're saying when we're between 64 and 78 degrees, open the windows for these hours. When we're not within that range, close the windows and then have the mechanical ventilation on. So these are the opposite of one another. Then we go and create two more schedules. One is we're saying, okay, when we are less than 64 degrees, so smaller, let's have the heat on. So that's going to be heating available. And when we're above 78 degrees Fahrenheit, let's have the cooling on, and that's this set of hours. And so this is just a schedule that we're sending. This is 4 schedules we're sending to Climate Studio. If I enable this, um, oh, I think it already was enabled, so it's going to have sent it already. I should set this as off. It doesn't matter. What I'm saying is if you keep, every time you change this name, it's going to send a new schedule. So if I come over here and go into my zones, I'm going to collapse them all, and I select them all, I edit them. This is where those schedules would be. Now, this is where it gets a little bit, I'm just going to tell you what's going on, and like I said, you don't even need to do this for to get outputs and to have something to show in your final exercise 13. But I'm noticing here in this template that I chose, we already have a heating and cooling schedule, and I'm sure it's pretty okay. It's certain hours. It's not based on temperature. But maybe that's good enough. So I guess I'll leave that. I won't bring in the heating and cooling, above 64, less than below 64, above 78 schedules. But I am going to bring in the mechanical ventilation schedule. So if I click on this and scroll down to the bottom, because that's where they are, I can find, you see this climate thing came in. I don't want any of those. Well, it's going to be the same because I didn't change anything. But I want to use my NYC because that's what I called it before. So I'm going to use the mechanical ventilation NYC, okay, and then I'm going to turn on natural ventilation. And there's another video on this, so I won't go into a lot of detail about it, but all I'm doing is bringing in this natural ventilation. Oops, wrong one. That would be exactly, I'll show you. See that this is the climate one, this is the generic, exact same, because I didn't change anything. Just I sent that with the climate name on it because I had it enabled when I didn't think it was. So now I have natural ventilation. So I'm basically saying the windows are going to be open um, when it's between 64 and 78 degrees. The stack driven flow just means I'm not using cross ventilation. I'm just saying it's just pressure differentials when the windows are open. Um, and just to show you, there are settings for the windows, um, but there should be, let me just, I'll use one to open up one so I can look at it. So the basement doesn't have any windows. Um, I actually hadn't added the windows yet, I guess. So I'm going to select all my glazing here. I'm going to choose, let's see, I'll go to value. This was the one I think I chose. But here's what I wanted to show you. So I'm in the ventilation settings. I can change the amount of operable. So when I have the window open, how much of that square footage is actually having, how open can the window get? The rest of these are just presets we can leave. But this is showing when the windows are open and how much air is coming through them. And you see, so not to confuse you, I'd run this before. That's, I didn't run the actual simulation to get this output. So I'm assuming you knew how to do it, but I had not actually put the windows in this time around. So I selected all my windows in my energy use template and selected the add edit window, and here they are. They are all there now. So I know I'd showed you that before, so I'm not sure what happened to them. Anyway, so if I ran this, and with natural ventilation, I got a slight reduction. Not even that slight, it's a 3 or 4% reduction in site EUI from the non-natural ventilation version. So that's a good iteration. And there's lots of things you can do to talk about ways you can improve your envelope by looking at the outputs. We're not going to get into that right now. We talked about that in class. I'm just trying to remind us how to go through these processes and how to set up your model to work for all our workflows. Okay, so we now have a thermal analysis for our project. Well, we use the thermal analysis and natural ventilation to get an energy use simulation. Now, to figure out how much energy use we're actually how much energy the project actually will use, we need to estimate how much photovoltaics we might create, how much renewable energy we can create that then can offset some of our usage on site. So let's do that next.